Hello, everyone.
Welcome, everyone, and we're together again for this day's episode of Explore and Learn at Twing. So that's the second episode, and yesterday we learned all about outputs and inputs with Baha's help. And today we're going to move on to something new, conditionals. So we'll be discussing lots of if and else statements, and other than that, we'll have prize questions and experiments. So be sure to listen us carefully. And so one of the questions that was asked yesterday was, how does the binary system work? So as Baha told us about it, like how a letter is like an input and the output is something like a string of ones and zeros, and that's something for computer to understand. And then I came across a picture, lots of peas and carrots. So Baha, can you show us that one?
Here you go.
Yes. As Baha opened the picture, there you can see like little peas and some pieces of carrots. So it looks like a vegetable soup trying to become ready, but it's actually a binary system that is made with carrots and peas. So instead of ones and zeros, we could use something like that. And we could even write our name. So for example, I created my own binary system with arrows. So I have two arrows, one's for, I mean, the down ones for zeros and the upwards ones are for ones. So there you can see my name, Ekin, and every letter is associated with a string of numbers. So when I converted these numbers into arrows, so there I have my own binary system. So you can create your own ones and share it with your friends using our mobile app Twing. And now we have today's experiment. So it's called the Mobius Strip. And Baha, as you're now majoring in mathematics, can you explain us what Mobius is?
Well, a Mobius strip is really interesting. It's a special piece of paper that only has one side. So a normal piece of paper would have two different sides, but when we turn it into a Mobius strip, it actually only has one side.
So let's see if it really has one side. So here I have a piece of paper that's yellow, and I'm going to cut a small part of it. There you go. Yes. And now I have the string. So as Baha said, it's now double-sided. One's here and the other one's here. I just need a piece of tape as well. So let me get it. And now I'm going to stick one side of it here, this end. And I'm going to make circles. And instead of just sticking it here, at the very last minute, I should be turning this upside down and then attach them together. There you can see. But Baha said something interesting that while the first version of this paper had two different sides, now it has one. So let's check if that's true. I'm going to put my pencil on it and try to draw along with it.
So if you had a normal piece of paper that had two different sides, then you could only cover half of the paper, and one side would be left untouched, right? If you did something like this.
You're right.
So now let's see what's going to happen when you keep tracing the paper like this. So what she's doing is she's drawing one continuous line all around this Mobius strip, and we'll see what's going to
You're
happen
right.
if the pencil is going to reach every single part of this piece of paper.
I ended up where I started. So I started here to track down it and then came all the way here again. So
Oh,
it's
that's
like
so
it's really like a
interesting.
continuous loop, but it reminds me of something else, Baha. What do you say?
Well, I already know the answer to this question, so this looks a lot like the recycling symbol. So the logo that is associated with recycling is actually the Mobius strip. And the reason why it's chosen like that is the Mobius strip is an infinite piece of paper. You can go around it continuously. And by recycling, we're actually using the same materials again and again. And even though we may not use them infinite times, it's still this continuous loop that keeps feeding itself. So that's why the symbol for recycling is a Mobius strip.
Yeah, so remember this new topic that we just introduced, and you can always check this out and try your own using our mobile app Twing. So let's continue with the new picture. I'm curious what you have for us today, Ba.
Well, I see that you shared with me the image of a tree. It looks like an apple tree, right?
Yeah, it's an apple tree, but is that a special one or just a regular apple tree?
Um, well, I've actually been there and seen that apple tree, and
You
I
been
know
there?
that that's the apple tree that when I visited Cambridge for a short amount of time, and I actually had to visit this tree to sort of see this important historical place, and that's the tree that Newton was sitting under when he sort of formulated the law of gravity, right?
You're right. So that's the apple tree Newton set down. I mean, the one throughout the history that's one of the most important apple trees. So it has another story actually. While most of the people think that Newton derived the formula for the law of gravity, although it's true, it's not the reason why this apple tree is important. Uh, I mean, he first realized that the Earth has some gravity, and that's why the apple is falling downwards. But the other than that, he began thinking, what if the moon itself was pulling towards the Earth? So, and it's the same with the moon. So, what if the moon was pulling the Earth back to itself? So, after he began thinking about this, then he derived the formula, and the, our whole perception of the physics and the universe around us shifted a little bit with his new idea.
Wow, that's so cool. So it is the same force that draws the apple towards the earth as the force that keeps us rotating around the sun and prevents us from flying off, right?
Yeah, you're right. And while he conducted this, I mean, let's call it an experiment. So years later, Einstein came forward with a new idea that even made our thoughts go further a bit. So his version of the story wasn't quite like the Newton's, but let's keep it that way, and it'll be a homework for you to discover.
That's great. So we also have this really cute image of Isaac Newton.
You're right, he's holding an apple.
So now actually, there is a fun fact that's associated with this as well. Um, Newton was affected by the plague when he was working. Um, just like some of you might be doing right now because of the coronavirus. Newton had quarantined himself during this plague, and this was actually a really important time for him. And he did some really important calculations and discoveries during this time period. So even though he was under quarantine, he used this time extremely effectively. And not only did he learn lots of interesting new stuff, but he also did something really valuable for the rest of humanity. So
You're right.
I hope
Wow.
that some of you will spend this precious time really effectively and maybe do something as important as this.
You're right, Baho. I mean, schools were shut down at this time, I guess. And he was forced to move back to his home. And even though he moved back to his home, he continued his studies and then discovered this whole new world of physics.
And something else that you can maybe discover today is who won the competition yesterday, who is going to win the prize.
Yes, the
And would you like to
winner
announce the winner,
is,
Ekin?
yeah, sure. Drum roll, please. And the winner is Burcu Yenoğlu. So congratulations, Burcu, and please be sure to contact us using our Instagram's page, and we'll contact you soon.
That's great. So let's, well, we talked a bit about Ada Lovelace yesterday, and we also have this image of her working on her studies. And since we've talked so much about programming and the mother of programming, let's do some programming of our own. Let's all go to code.twinscience.com as we did yesterday, and today we'll do something really interesting, something that we hinted at yesterday but couldn't really start. Let me share my
Are you
screen
going
with
to
you.
tell us, Bob?
So yesterday we had focused on this part of the screen, the yellow box.
Mhm.
These represented our inputs. So we are going to still be using this to some capacity, but here is the major place where we're going to focus on today, and it's the control part. Most specifically, these two blocks. If then and if then else. Uh, well, the word if is something that we use a lot in our daily life, right? Again,
Yeah, but before we go any further, I was wondering, is there an chat box kind of thing, just on top of our friend?
you mean this little box between if and then?
Oh, no, not really. The one, if you move your cursor towards the sprite.
Oh, that's something that I was doing on my own. Okay, now
So
it's
you're
gone. Okay.
conducting your own experiments, right?
Yes, I was doing something before we even started, so I'd highly encourage you to not stop doing your experiments when this live stream ends. Please keep doing some more interesting stuff and share them on Twing, the app, so that other people can see them and take inspiration from them.
So now we can explain to me what does little box means. It's
Okay,
one between
so
if and then.
that's really nice. So, Akin, can you form a sentence using the word if, something that you would say in your daily life?
Let's see. If schools are shut, uh, now I have more time to study on my own.
That's a really nice sentence. Before we started recording this, I was speaking with my friends, and for example, they said that if the light is on, turn it off. Um, the word if is something that we use a lot in our daily life, and we sometimes do it intuitively without thinking of what it really represents in our language. So programming really allows us to think of what the specific word means because we're going to use it in a very specific way. So let's see.
A more
Um,
simpler sentence would be like, if it rains, take an umbrella with yourself. Something
yes,
like
that's really nice. Um, so uh, that actually ties really nicely to the topic that we're going to discuss today, which is conditions and conditionals. So you said that if it's raining, then take an umbrella with you. So what I should do is maybe I'll look out the window before I go out, and if it rains, I'll take the umbrella. And if it doesn't, I won't take it.
So
So
you should
me,
first check it if that's true or not.
yes. So me taking the umbrella depends on the weather, whether it's raining or not. So there is a condition there. The condition is the rain. And I need to keep that in mind before I commit to what I'm doing. And we can do something like that right here. So here, we're going to put this block right here, and you'll see this little box between the words if and then. Now, we have to put something in there, something like if it's raining, right? It doesn't really know what to check right now. And the
What should it,
computer, again, what was your question?
what should it check? I mean, Sprite has no eyes or no.
That's a really nice question. Um, so what we can do is give the computer a statement, and what it can do is check if it's correct or not, whether it's true or false. If the statement that we give the computer is true, then it can do something accordingly. So let's give it a statement. Since I'm a math major, I'll choose something mathematical. For example, here we have equals. Let's check if the numbers 3 and 5 are equal. So I'll put it right here.
Mhm.
So if 3 equals 5, then we're going to do something. So let's have our friend
I wanted
say,
to move toward,
you
and
are
can it also
correct.
move forward, right?
Excuse me?
Can it also move towards right if it's
Yes, of
correct?
course. Yes, let's have it move towards the right if it's correct. So it will say this and then move. Let's press the button. Well, nothing happened. Again, why do you think nothing happened?
I mean, obviously, 3 and 5 are not equal to each other.
Yes. So let's change this so that it's going to check whether 5 is equal to 5. What do you expect to happen, Akin?
Now let's just say you're correct and move 10 steps. But I'm
Let's
not
see.
sure towards where.
Let's see. Well, it did. The sprite moved towards the right and said you're correct. Um, so when we were just doing this, when the statement that we gave the computer was not correct, what we got was nothing, right?
Yep.
So that doesn't really help us when we're doing this in different places. Sometimes we need to know that what we're checking is incorrect, right?
You're right. So can we use the other orange block?
Yes, that's exactly what this is for. So I am going to move all of this stuff into this other block and get rid of this. Okay, so now we have a block that is almost the same with an extra part at the bottom, the else part. So let's add something else over there. Let's have it say false. And then instead of moving, maybe the sprite will turn 90 degrees. And instead of checking this, maybe we can do something else. We have some other interesting green blocks right here. For example, let's pick the greater sign. Oops, that's the wrong place for it. Here we go. If, let's say, 100 is greater than 50, it'll say you're correct and move. And if it's false, it'll turn. Okay?
All right.
Let's see. Well, our friend keeps moving every time I press this button. And let's do something else. Let's check if 10 is greater than 50. When we do that, well,
False, and it turns like.
that's exactly. So we can see that if what if the statement is correct, then it does the part that's under if. And if it's incorrect, it does the part under else. Well, sometimes we need to do something a bit more different than this, right, Akin? So for example, maybe we have to check more than one condition. Do you have any idea how we can do that?
More than
I think we're experiencing some technical difficulties. Akin. I had some problem hearing what you're saying. Maybe it's about my internet connection. Could you please repeat what you just said? Or maybe I'll quickly check my internet connection.
Baha.
Yes. Hello. Hi, Akin. Okay, I think I had some troubles with my internet connection. So now we're back. Hi.
So Baha, can you hear me?
Yes, I can hear you really well right now. Let me
All
just share
right.
my screen again.
I guess your question was how could we check two conditions at the same time, right?
Yes. So for example, if it's raining outside, I'll wear my coat because I don't want to get wet. I'll also wear my coat if it's snowing outside. So if either one of those are correct, then I will wear my coat. How do you think we can check something like that?
So it's like rain and snow that we should check. And I guess we have another block for that, just on the left side of your screen, the end block.
Well, we have two different blocks, and or. So what I asked you was something that would work in either case. So I would wear my coat if it's raining or if it's snowing, right? So which block should I use for something like that?
So it should be the or one, I guess.
Yes. So with or, we're going to check for two different things. And even if only one of them are correct, then the whole statement is true. And we get the result accordingly. If both of them are true, that's great. It's still true. For the OR block to produce a false result, then both of the cases that we check for have to be false. So only one of them being true is enough in our case. So for example, we'll do something with these blocks. Sometimes these are a bit difficult to get right. So let's check if the number 75 is greater than 50 and also less than 100. So our friend here is going to say true or false. Okay?
Okay, I'm ready.
So let's try. Well, what happened?
But Baha, isn't I mean, aren't both of them conditions are correct?
Yes. So let's try something else. What is greater than 500 or 75 is less than 100? What do you say? Let's go.
So,
Well, it's still true, Akin. Why do you think of that?
so there we have like two conditions, and as you said before, it will be enough for us to see the correct answer, as long as one of them is true.
Yes.
And the second one is true, so therefore Sprite says true.
Yes, you're right. But if both of them are false, what do you expect us to see? False. So when both of these are incorrect, then we get to the else part, and the sprite says false. The AND block is similar to the OR block in some ways, and different to it in some others. So let's check the AND block when both of the cases that we give it are false, okay? Let's get rid of this. So Ikin, what do you think will happen when both of these are false?
Both of these are false, so if false, then it should say false.
Yes, false. And what if one of them is correct? For example, 75 is greater than 50, that is true. But the second one is incorrect. What do you think will happen?
So as we're using the block AND, I guess it should stay false.
Yes, with the AND block, both of the cases that we give it, both of the conditionals have to be true for us to produce a result that is also true. So the only way that we can get the result true from this is if we correct both of these statements. So if we go back to the original one where both of these are correct, then we get true.
So I see where you're going with it.
Yes. So now we have these two different blocks, or and, to check for two different conditions. Let's see what this one's going to do. And we'll do something a bit more complicated with this. So I'm going to pick one of these. And also this. So let's do this without using the not block first. So if 10 plus 40 is equal to 50, then let's say our friend will let's see what's going to happen. And set true. So here we used 10 plus 40 as our number, and therefore we checked whether 10 plus 40 is equal to 50. Well, we can also add the not block now and make things a bit more interesting. What do you think is going to happen when we add the not block, Ikin?
If not, then that's a tough one. I mean, it's all confusing, but at the same time, it's also still fun. So I guess it should say false.
Yes, what the not block does is it inverts everything. So everything that was true becomes false, and everything that was false becomes true. So when we run this program again, we see false.
False. But Baha, all these mathematical equations are just for you. I mean, I know you're a math major, but can we do something more fun, like moving the sprite all around the places? And just yesterday, you showed us how we can use our keyboard's keys to operate sprite. So what if we did something like if key pressed, then moves the sprite?
That's a really idea. So let's get rid of all of these and try it that way. So for what you just asked, we don't need the else part. So we go with the simple if then part and it's move towards the right. So let's add this right here. And now we're going to see if the key is being pressed, right?
Yeah.
Let's look at that. So we are going to be picking this block here. And the reason why we're going to use this different block is because this is not going to be the beginning of our code. The ones that we use today, we're going to go to the sensing part and pick this. So when the right arrow is pressed, then, okay, let's see.
I'm ready. Did it just?
So here's something interesting. When I just press this green button, it doesn't move. But when I press down the right arrow and then press this green arrow, it moves.
So I have another question for you.
Yes.
I mean, once you press down the right arrow, do you still have to start the program again by using the green flag, or can you just move on doing the same over and over again?
That's a really good question. So our friend only moves if the right arrow is being pressed when we run the program. And the reason for that is when we run the program, it checks whether the button's pressed, does something accordingly, and then the program's over. There's nothing else to be done. It doesn't continuously check whether the arrow is being pressed. And if you want to learn how to do something like that, then I suggest that you keep watching, because that's going to be something that we're going to discuss. So now that we've done this, maybe we can go back to what we've discovered today and go back to our presentation and discuss the stuff that was in today's lesson, okay?
All right, so now I'm getting more curious than ever. I mean, you're going to teach us like a continuous loop tomorrow or the day after that?
Loops are, and I suggest that you keep watching to see when that's going to happen. So to recap what we've done today and what we've done yesterday, yesterday we started with inputs and outputs, and sometimes in the middle we have the processing and the storage. And today we discovered this. So we had some input, right? Pressing the green button to start the program. And then we gave the program a condition. For example, whether 5 is equal to 2. If this was true, or whether this was false, it went to two different options. If we were using an if-else block, then the true statement showed us to what's under the if part, and if it was false, we went to the else part. If
So
we only, yes.
Yeah, now that I see the scheme, like I guess it's called a flow chart, right?
Yes, this is called a flowchart, and this is used to show how the program flows and touches on different parts of this.
So, I mean, there is a condition, and if it's false, it chooses one option, and if it's correct, it chooses the other option. So it's like a quiz show. Am I right? Like you could build your own trivia questionnaire.
By using this system and do lots of fun games and different activities. Maybe this can be a project that you can do today. Create your own quiz and test other people.
So this flow chart is like for us to understand. I mean, the computer obviously couldn't handle all of this shapes and text. I mean, it wouldn't know what to do with it.
Yes, a flowchart is something that programmers use to show each other how a program works. And sometimes they'll draw their own flowchart before they even start programming, so they can visualize what they're going to do before they even start writing their code.
So I think there's a word for programmers to describe how their program works, and it's algorithm, I guess.
Yes, word algorithm. What do you know about the word algorithm, Akin?
What did you ask, Baha? I couldn't hear you well.
What do you know about the word algorithm? Akin, do you know where it comes from?
Algorithm. So it's like, I mean, I think it's definitely in English, but I guess it derived from Latin or Spanish.
Well, Spanish is, well, they're not quite accurate, let's say. So, in fact, it's actually taken from someone's name, Al-Khwarizmi.
I don't know
He
who.
was he was a mathematician, an Arab mathematician, who developed the fundamentals of what we can consider algorithm today. So his name over time turned into the word algorithm, which is the way that we describe how programs work. An algorithm is basically a list of steps that need to be done. And we can easily translate that into code to tell a computer what to do.
So can you just go back one more time to
Yes.
let's see the flow chart again. So
Okay, here you go.
this an algorithm, right?
Well, this is an algorithm, but an algorithm is a very loose concept. As long as you have a strict list of things to do that are well defined, you have an algorithm. An algorithm can then be turned into a flowchart, or the algorithm, it can be represented by this flowchart, or it can be turned into code for computers to understand what we're talking about.
So let's say, I mean, I'm going to try to give you an example what an algorithm is. So correct me if I'm wrong. Um, First of all, the number one step, I wake up. The second step, um, I go to the kitchen. And the third step is, um, let's say if I'm hungry, I'll make a cereal. And if I'm not hungry, the false part, I'll wait for another 15 minutes.
That's really nice. But if we want to describe this to a computer, then we need to be even more specific. For example, to go to the kitchen, you first have to exit your own room and then
Oh,
walk down the corridor and then open the kitchen door. Or if the door is already open, just go in directly. And then you have to open the fridge, get the milk out. So we have all of these really specific steps that we need to include in our algorithm so that a computer can understand everything that it needs to do. A computer doesn't know what cereal is. We need to be really specific and tell it exactly what to do.
well, I'm sure I know what cereal is, and that's the only breakfast I eat in the mornings. But I would not advise it to others.
So um, now I think we can talk a bit more about the Twing app, Akin. Do you have something to say about that?
Sure. So yesterday we did the soap and pepper experiment, which allows us to understand or a little bit more about how viruses and soap work. And today we did a Mobius strip. And now we're going to announce a new prize experiment. So Baha, again, can I have a drum roll, please?
Wow, what is it? Yes, it's on screen. Hello.
Baha, you're back.
Yes. Yay, hello. I think that was a tiny problem in the connection. Yes, I'm back.
So, as I said yesterday, with a salt and pepper experiment that allows us to understand more about how viruses and salt work. And today we made a Mobius strip, just like here. And now we're going to announce a new prize experiment that you can do on Twing. So, can I have a drum roll, please, again?
Yes. Well, I already, I think, shared the experiment. So.
Yes, you already shared it, but that's okay. So
yes,
I guess we'll have to save the drum roll for the videos then.
yes,
So,
we're really excited to see your videos.
so be sure to download the app and post your own version of this experiment. And then tomorrow at the same time as today, we're going to announce who the winner is. I mean, the person who gets the most likes. And then we're going to award a new twin coding set again.
So invite your friends to the app and have them like your stuff, as well as encourage them to do their own experiments and upload those videos as well. I actually just received a notification on my phone that this challenge was uploaded. So if you stay tuned to the live streams and to the app, then you can be the first ones to learn what the experiment is and get a head start on getting those likes.
So thank you, everyone. We'll see you tomorrow.
Hi. Bye. So we'll see all of you tomorrow with even more interesting science and coding content. Take care.
Bye.